the discriminant is extremely helpful to determine how many solutions your quadratic has and also what type. So we're going to talk about that here at the top. All right, so the discriminant is actually within the quadratic formula. It is the b squared minus 4ac that's under the square root, but it does not include the square root. So if you're looking at the quadratic formula, sorry, I have this in color on my actual file, but the discriminant is not including the square root, just what's under the square root in the quadratic formula. Okay, now there's three different things that can happen, and we worked with all three of these yesterday. But when you have a discriminant, it could be a positive number, it could be a negative number, or it could be 0. And that value will tell you some information about the solutions to your quadratic equation. Okay, so I'm just going to make something up, just totally make something up. So let's say you went through, you did the quadratic formula on a problem. I get a negative value of discriminant. I'm just going to make this up. Let's say we had something like, I don't know, -4 plus or minus square root, and we had a -5, and I don't know, maybe the bottom was 2. I'm just completely making this up. But the point is, whatever we got when we did the quadratic formula gave us a negative number under the square root. Okay, what do I know about my solutions if there's a negative number under the square root? No intercepts, right? Okay, so if you have a negative number under here, that's going to have you simplify in some way to get an I. So actually, it's also going to tell me we're going to have imaginary solutions. Does anybody know how many solutions I would have? 1, 2, or none? Just because it has an I doesn't mean it's not a solution. You're going to have 2 because you have the plus or minus. You're going to have 2, and they'll be imaginary. Because you could do -4 plus, it'd be I radical 5 if I simplified that. But you're going to have 2 imaginary solutions. And that plus or minus is what gives you the two solutions. One's a plus, one's a minus. We would just, it's simpler to just leave it in that form so I don't have to write that complicated fraction out twice, one with a plus and one with a minus. But that does represent 2 different answers. You could actually, I know, if we actually had a quadratic formula, I know this is weird, you could do this on your calculator, you could actually plug this in for x and it would make it true. Because you'd end up squaring the I, and then it would cancel the I out and give you -1. So this is something, theoretically, it's just not a physical thing that you could see on the graph. So that's what I do have over here. In an actual situation where you had the graph, you guys will see these are just 2 little examples. One's if the A value is positive, one's if the A value is negative. But it's not actually going to be something you could see on a graph. But if I plugged in and used our properties that we talked about with I plugged it in for x in the equation, it would actually make the equation true. So 2 imaginary solutions. Physically, though, on a graph, you would have no intersection with the x-axis. All right, now the questions today are going to ask you for the number and type of solution. So in this situation, the number of solutions would be 2, and the type would be the fact that they would be imaginary. So the number is how many solutions, the type is what type, like is it real, is it imaginary? All right, now I'm going to make up another scenario for you. Okay, let's say we did the quadratic formula. We did one like this yesterday. And we get something like 3 plus or minus, and I end up with 0 under my square root. And I don't know, maybe the bottom of this is 2. I'm not being very creative today. So, if the discriminant, b squared minus 4ac, ends up being 0, this would really just simplify to be 3 plus or minus 0. I just made this up, right? But if I add 0 or I subtract 0 from something, it's not going to change that thing. So this would just give me 3 over 2 would be the solution to that I just sat there and made that up. Okay, so how many solutions does that actually have? Just 1. So this has 1. Would you tell me it's a real solution or imaginary? Real, because I don't have an I in it. So you'd have 1 real solution. And then visually, we saw one of these as an example yesterday, but this is a situation where just your vertex just touches the x-axis, that's the situation where you would have one solution, and you could physically see that on a graph. So the number here, again, the number of solutions is 1, and the type here would be real. I don't know why I just wrote real again, but that is the type, is what I'm saying. All right. Now, the last situation that you're going to have, and it's going to depend on the problem. So let me make something up here. If I get a positive number as my discriminant, there's two different things that can happen to influence how I would write this. So I'm making something up. Let's say I have 5 plus or minus, I don't know, let's say we get an 81 under the square root. Maybe that's divisible by 2, I don't know. Just making it up. So I went through, I did my discriminant, maybe I did the whole quadratic formula. If what you have under the square root is a perfect square, then you're going to have there'll be real solutions, but what I'm going to add to that is that those solutions will be rational. So rational just means anything I could write as a fraction. So maybe my answer is like 3, or maybe my answer is -5. Also rational would be like a 2/3, or like 3/4 would be rational, 5/2 maybe. It's a nice number. It doesn't have a decimal. It would be something where we could take the square root. We're not going to have a radical in the problem. So basically what this means, these are going to be nice numbers. We're not going to approximate anything because it would be a nice fraction for our answer. The other scenario, if you have a positive number, I'm just making something up here. Let's say I have -6 plus or minus, I don't know, I got 11 under the square root. That's not a perfect square. Just making these up. Okay, if I take the square root of 81 here, that's 9. It's a nice number. You take the square root of 11, anything that you take the square root of that is not a perfect square is some garbage decimal that's irrational. This is always going to be something that is a decimal that has no pattern. If you tried to convert this to a fraction, like if I did my math enter, and it would just spit back out the decimal to you, what that means is it can't be written as a fraction. So this is what we call an irrational number. Rational you can write as a fraction, irrational you can't. So if your calculator can't convert something to a fraction, it means it can't. All right, so this is still 2 real solutions, but they're going to be irrational, which just means we're going to have decimal answers for that. So if it's a positive value under your square root in your quadratic formula, you have 2 real solutions. If it's a perfect square, there'll be nice numbers. If it's not a perfect square, there'll be nasty numbers, but we'll still have 2 real solutions. And so if you guys look over here at the graphs, I just have 2 different possible, depends on whether the graph turns up or down, but this would intersect the x-axis in 2 spots. And they might be in nice numbers, they might not. It just depends on what the actual quadratic is that you're solving. All right, so you guys will see questions like this that will literally just say, okay, here's this quadratic formula, and it says determine the number and type of solution by doing the process of finding the discriminant. So we're just, for each one of these, I'm going to write it again so you guys can see it on the screen, but it's just b squared minus 4ac. It does not include the square root. So like for this one, I would do -6 squared minus 4 times -3 times 1. And I'm just going to figure out what that is. And if that's negative, it tells me something. If it's positive, it tells me something. Or if it's 0, it tells me something about the solutions. So it doesn't matter what the number is. I got 48. Okay, this is positive. So that means I have 2 real solutions. Really what I was talking to you guys about in terms of splitting up the positive solutions is really more useful for what we're going to do on the back. You don't have to say that they're rational or irrational, but this would be 2 real. In this case, that's not a perfect square, so they would be irrational solutions if you want to write that. I just really need you to be able to tell me it'll be 2 real solutions. They're not going to be nice numbers for that particular graph. If I do this one, my b squared would be 4 squared minus 4 part of the formula. A value is 1, c value is also 4. So you should get 0 here if you do this. 4 squared minus 4 times 1 times 4. This is 0. So that'll be the second situation. If it's 0, that means the vertex is going to be the solution. So this would have one real solution. Now, if I do discriminant on this last one, b squared is going to be 5 squared. 4 times the a value is -2. C value is -13. So I'm just plugging that discriminant in to my lovely calculator. 4 times -2 times -13. Doesn't matter what the number is, it just matters whether it's positive or negative. Because this is negative, we'd be taking the square root of this, so I immediately know here I'm going to have 2 imaginary solutions because we'd have an I in the answer. Those are the only 3 things that can happen. 2 real, 1 real, or 2 imaginary. Does anybody have a question? Okay, now, this the top part of this is kind of why I was talking to you about whether we had a perfect square as our discriminant. Okay, so it says if the discriminant is a positive perfect square, like I just listed some perfect squares for you. These are up on the board too. So if we take the square root of any of those numbers, we get a nice value. There are 2 real, like I told you, rational solutions. What that means is if you get a perfect square under the square root and you're trying to go through the quadratic formula, the quadratic will be something that you could factor. So I'm going to write that it'll be factorable because it's not going to have a radical in the answer. So if you go through the trouble to finding the perfect or the discriminant and you get something that's a perfect square, you'll know you could factor that quadratic. Okay. These are the 5 methods that we have talked about for factoring quadratic equations, or not for factoring, for solving quadratic equations. So, like, when should we use which method? Okay. In terms of each one, and it kind of depends on the equation, like how you want to look at it. Graphing, I would use graphing like if you have a graph. Like if they give you a picture of the graph, sure, we could use graphing to solve. What you're looking for if you're solving by graphing is your solutions would be your x-intercepts. And if you have a graph, or if you are allowed to use maybe Desmos or your graphing calculator for the question, or it asks you to use one of those 2, it's trying to ask you to solve by graphing, that would be the method I would pick. I would also say this would be a decent thing to do if it's just something, if you have to estimate your answer, if it would say something like that. You would not use graphing if you had imaginary solutions, because you would not be able to see the solutions from a graph. So if you know you have an imaginary solution, you don't want to use graphing as your method of choice. Okay, now, 2 things for factoring. I just told you this. If you do the discriminant, b squared minus 4ac is a perfect square, you'll know that you can factor it. At that point, if you've gone to the trouble to find the discriminant and find out that it's a perfect square, I might just go ahead and use the quadratic formula, but that's just me. So the other way is if you just look at the equation, if you can quickly think of, you know, multiply a times c, add to b, if you can quickly think of those while you're looking at the equation, that might be a fast way to do it. Otherwise, like I said, if you go to the trouble to find the discriminant and find out that it's a perfect square, you might just go ahead and use the full-on quadratic formula. All right, square roots. There's 2 situations. And I'll just give you a little example. So, like we have no linear term, I'm going to put b times x. So a situation like that, like maybe we have, I don't know, x squared plus 6 equals 50 or something like that. I can get x by itself there just by subtracting 6 and taking the square root. There's no linear term for me to have to worry about. The other scenario where square roots are really good is if you have something in parentheses. Like let's say we have, I don't know, x minus 5 squared, I don't know, I'm just making something up, equals 64. If I have something like that, we don't want to FOIL it out because we can do the same thing and cancel the squared out by taking the square root. So anything in I can get in that format with the parentheses, or if you just don't have an x term, you just have an x squared plus or minus something equal to something else, you can solve that with square roots. Okay, now we went through multiple questions where we were doing completing the square. If I'm being truthful with you, I don't mind the fractions, but I would say if I was doing completing the square, I would want to pick a situation where my a value was 1, so I didn't have to mess around with some of the stuff we were doing the last couple of days. And if b is even, that's easier to work with. And if you remember, for completing the square, the reason I would say b to be even would be a good way to pick that. You end up doing b divided by 2 squared to go ahead and complete the square. So if b is an even, that's a nice number to work with. If you didn't mind working with the fractions, though, like if b is 3 or something, you could also use completing the square for that. But I would really recommend a different method if your a value is not 1 versus completing the square, because it can be a lot of work. All right, now, quadratic formula. You can literally use the quadratic formula on anything. I might say I would personally lean towards this if the a value is not 1. That's just me, but that's totally up to you. You can use the quadratic equation to solve any quadratic, and I put a little asterisk back next to both of these. You can technically use completing the square also to solve any quadratic, but you saw a couple days ago we were working with that. That can actually lead to some really garbagey stuff that you're working with. So it might not be the best choice unless you enjoy working with fractions a lot. All right, so we're not going to solve any of these. We're just going to say, like, what would we maybe do? Go ahead.
So for any of these, so I know you're going to say, solve by factoring, but will you give us circumstances where you can't easily multiply a times c and have b?
Yeah, and so that, like, okay, gut instinct for me. Like, if I'm looking at this, just in, whatever. If I wanted to actually do the discriminant like we're doing today. So if I did, let's see, b squared minus 4 times 6 times 3. Let me just see what it is. Okay, I get that that's 49. At that point, I have gone through and almost done the entire quadratic formula, because if I find the discriminant here, like all I would have to do is opposite of b plus or minus the square root of what I just found over 2a. 2 times 6 would be 12. So at that point, I've determined it's factorable, but at that point, I would just do the quadratic formula, because I've already done all the work to figure that out. Also, so I know this is factorable because I just showed you guys the discriminant. So I could factor this. I might, because I like the Berry method, but this would be tricky because you've got a number in front of the x squared. So you can factor this. I would probably, at that point, just use the quadratic formula. I'm just going to write quad form to abbreviate that. But either one of those would be good. I for sure would not complete the square on this, because that you're, go ahead. Is that what you're going to say?
What I really meant is, like, I know on the test you're going to give us, like, solve this.
If I say that to you, it will be, like if I say solve this by factoring, it will be factorable.
It won't be.
No, it will not be. And if I say, here, you pick the method of your choice, you could solve every problem using the quadratic formula if you wanted to. You could solve every problem using completing the square. I'm not going to judge one way or the other. It's your choice. Now, this one, can you think of factors that multiply to get you -8 and add to get you 5? No. I would use... If it was me, I would use quadratic formula on this. You could do, I'm going to abbreviate, I'm just going to write complete the square. You could use complete the square on this, but the b value is 5. So you would do 5 divided by 2 squared. So if you didn't mind working with the fraction, you could do that. Either one of those would work for that, but I can't factor that, so it'd be one of those. You could, if you had a graph in front of you, you could graph it maybe. This one, I would definitely use square roots. Because I see that set of parentheses, I could isolate that, get that by itself, take the square root, and get rid of the parentheses. Do not FOIL those out. Personally, I look at this and I go multiply to get 10, add to get 7, and I immediately think, okay, 5 and 2. and then my answer's -5, -2. That's, if you can think of them pretty quick, that's a lot faster than using the quadratic formula or completing the square. But I would say this one I could factor pretty quick. If you can't think of it right away, you can always use the quadratic formula. You can always use completing the square, which I'm just kind of abbreviating. But my go-to on that would be factoring, because I could think of the factors real quick. This one for sure, you don't have an x term, you just have an x squared. So for sure this one, I would say square roots would be the fastest, because all you have to do is add 1, divide by 16, take the square root. Like we'd have 16x squared equals 1. I'd divide by 16, and then both of those guys are actually perfect squares. You just have to remember, when you introduce the square root, you got to put the plus and minus, and that gives you 2 answers. It would be +1/4, -1/4, but that's super fast. Okay, now this last one, if you like completing the square, I would either use, you can't think of factors of 17 that add up to -6, so this is not factorable. So I would either use quadratic formula, or I might lean to complete the square on this. The reason for that is because that b value is an even number. We would just move the 17 to the other side real quick, and then if I complete the square, remember, you just grab the b value divided by 2 squared to get your perfect square trinomial. This one I'd have -6 divided by 2, which would be -3 squared. So I would just add 9 to both sides, and if you can kind of do that pretty quick, this would turn into x minus 3 squared. What is that? -8. And then I would just take the square root. So it's totally up to you. You can use the quadratic formula on any question. Complete the square you can use on any question, but I would recommend like an a value of 1 and a b value that's even for that. And square roots factoring, it's just going to depend on looking at the question to see what you have. Is anybody having a question?